For topic 5, we're going to talk about probability and odds. Okay. So, odds, they're not too bad. It's just kind of thinking about the ways things can happen, the way they can't happen. Okay. But as a definition, which I probably should have added this, but as a definition, we're still talking about the likelihood of an event occurring. And that's kind of the heart and soul of what probability is. We're just like, hey, what is the chance this thing happens out of all possible outcomes? Okay. When you're dealing with odds, it's a little bit different. You're still looking at the likelihood of an event occurring. So this is the likelihood of an event occurring relative to the likelihood that the event does not occur. So imagine rolling a fair six-sided die. So we're going to look at rolling a fair six-sided die. What we're accustomed to at this point is like finding the probability of rolling a six. Okay. So what is the probability of rolling a six? Well, it would just be 1 in 6. Okay. But when we talk about the odds, it's a little bit different. If we talk about the odds in favor of rolling a six, in this case, we're like, okay, how many ways could I roll a six? Well, if you're dealing with a fair six-sided die, there's one way to win, rolling a six. So one, whoops. So there's one way to win, that's actually rolling a six, but there's 5 ways to lose, which would be rolling a one, a two, a three, a four, or a five. So we would say the odds in favor would be 1 in 5. Okay. Now we could also talk about the odds against. That would be kind of flipping it. Okay. There's 5 ways to lose compared to 5 ways to win. Okay. So there is a connection between probability and odds, and that's what we're going to kind of investigate in this video. Okay. So again, we're still looking at the likelihood of an event. We're still looking at the likelihood of an event occurring. We're just kind of comparing the likelihood that it happens to the likelihood that it doesn't happen. Okay. So if you're going from probability, you understand the probability, we need to convert that to odds. Okay. So if P of E is the probability of an event occurring, then the odds in favor are the probability that it happens divided by the probability it does not happen. Okay. The odds against would be the probability it does not happen divided by the probability it does happen. Okay. So that's what P of E and P of not E are. Now, for me, we can do the probability. We can find the probability of E, which is going to be some fraction. We can find the probability of not E, which is going to be some fraction, and then we can divide the two mathematically. But I sometimes think it can be a little bit easier if you think of this as like favorable outcomes, ways to win, and then unfavorable outcomes, ways to lose. Kind of like right here when we were talking about the odds in favor of rolling a six. There's one way to roll a six, think of that as like a win. There are 5 ways to not roll a six. Think of that as kind of like a lose. Okay. So the way we think of this is if we're dealing with odds in favor, favor is going to be pink. We want to look at the favorable outcomes, and we're going to divide that by blue, the unfavorable outcomes. So if we're looking in the for the odds in favor, we want the ways it can happen divided by the ways it can't happen, and then we simplify it. Now, on the flip side, if we're doing odds against, so think against blue, we would take the unfavorable outcomes and divide those by the favorable outcomes. So if you're looking at the odds against, how many ways does it not happen, divided by how many ways it does happen. Okay? So let's look at some examples. So for example 6, it says just find the odds. And I will tell you, you always want to reduce, kind of simplify your odds. We don't generally write it as a fraction. So like over here, let me scroll back up just a little bit. Over here, you can see I use this colon notation. We could write the odds as 1 in 5 or 1 in 5. And this is the typical notation here, but you would still need to make sure it's reduced, that each side of this doesn't have a common factor that could be divided out. Okay? So you're dealt one card from a standard 52 card deck. Find the odds in favor of getting a red queen. Well, you could do this technically, the probability that you do get a queen divided by the probability you don't get a queen, but I like to think of this a little bit more like favorable, unfavorable. So if we want the odds in favor of a red queen, we want the favorable outcomes, the ways to actually get a red queen, divided by the unfavorable, which would be the ways you don't get a queen. So we want favorable, those are going to be like the wins, divided by the unfavorable, and those are going to be the losses, meaning the ways it doesn't happen. So how many red queens are actually in a deck of cards? There are two. So of the 52 cards in a deck, we know two of them are definitely red queens. How many are not red queens? Well, 50, okay? So in a 52 card deck, two are red queens, 50 are not. We would then want to reduce this right here. So they're both divisible by 2, so we would get 1 in 25, but I would generally write it as 1 in 25. So for every red queen, there are 25 cards that are not red queens, okay? So let's look at part B. Part B says you are dealt one card from a standard 52 card deck. Find the odds against getting a red queen. So we want to go against the red queen. So the odds against the red queen. Well, when you're going odds against, you want unfavorable divided by favorable. Okay. So unfavorable would mean in the 52 card deck, how many cards are not red queens? Well, we already know that two of them are red queens. That means the other 50 are not. And then we want to divide that by the favorable. That's the ways you actually do get a red queen. So in a 52 card deck, there are two cards that are red queens. We want to divide. Both are divisible by 2. So we would get 25 to 1 or 25 to 1. Okay. Notice we simplified. Always make sure you're simplified. But what else I want you to notice is if you look at the odds in favor compared to the odds against, they're just flip-flopped. So as long as you're looking at the same event, in this case a red queen, the odds in favor and the odds against are always just going to be flip-flops of each other. Okay, so we had 1 to 25, those are the odds in favor of a red queen, and then we had 25 to 1, the odds against a red queen. And remember, odds in favor, there's one way to get a red queen for every, so I guess another way to say this is for every red queen, there are 25 cards that are not red queens. And then if you're looking at odds against, for every 25 cards that are not red queens, there's one card that is a red queen. Okay? It's kind of a mouthful, but hopefully you're following along. All right, let me get a sip. I have talked so much today and it's killing me because I've been making videos for hours now. Okay, so part C. A local bakery is running a promotion where one out of every 50 cupcakes has a golden filling and wins a customer a free cake. So you go to this bakery, you buy a cupcake. If it has golden filling, ta-da, you get a free cake. Okay? If 500 total cupcakes were made, what are the odds in favor of getting a golden cupcake? Well, this 500, while useful, doesn't really do anything for us. It's cool to know that, hey, they have 500 cupcakes. So of those 500 cupcakes, we know every 50 cupcakes, there's going to be one that has golden filling. So that tells me there are going to be 10 cupcakes total out of all 500 that have golden filling. But we honestly don't even need that. What we really do need to know is there's one out of every 50 cupcakes has the golden filling. Okay. So if one out of every 50 cupcakes has golden filling, how many don't? Okay. So one with golden filling, and then that means the other 49 out of that batch of 50 cupcakes, one has golden filling, 49 do not. I really am sorry. I just keep coughing, but I've talked so much today. Okay. So what we want to do is say, okay, if there are 500 total cupcakes, we don't really need that. What we have right here is plenty. What are the odds in favor of getting a golden cupcake? So if we want odds in favor, that means we want favorable divided by unfavorable. Favorable would be like a win, okay? So that would mean getting the golden cupcake. So how many golden cupcakes are there out of 50? One. How many are not going to have the golden filling? 49. So that tells me the odds in favor of getting a golden cupcake are 1 in 49. So for every golden cupcake, there are 49 that are not golden, and it's filling. So for every cupcake with golden filling, there are 49 without. Okay? So 1 in 49. Now, part D says a jar contains 80 marbles, of which 12 are green. Highlighter. So I'm going to go ahead and do 12 are green. And then let's do some other color, blue. 68 are not green. Okay, so we have 80 marbles total in a bag. We know of these 80 marbles, 12 are green, 68 are not. They're just some other color. Okay, so what we want to do now, it says if one marble is chosen at random, what are the odds against selecting a green marble? So remember, if you're dealing with odds against, you want the unfavorable divided by the favorable. Favorable would be getting a green marble. Unfavorable would be getting something that's not green. So how many not green marbles are there? Well, there's 68 not green. How many marbles are there that are actually green? 12. And we need to reduce this. So 68 out of 12, I believe 17, yeah. So 68 is going to be divisible by 4. 12 is divisible by 4. So 68 divided by 4 is 17. 12 divided by 4 is 3. So we would say the odds against selecting a green marble are 17 to 3. So I would generally write it 17 to 3. That means for every 17 marbles that are not green, there are 3 that are green. Okay? So that is probability to odds. Now keep in mind, this is technically probability that we can then convert to odds. So we take the probability something does happen, divide it by the probability it doesn't. But I think it's easier if we just kind of think of favorable versus unfavorable outcomes. Okay. Now, the last little part of this video is going to be doing the opposite. In the first video, in the first part of this, we technically knew the probability and we converted it to odds. What's going to happen down here for the second part is we're going to know the odds, we have to find the probability. Okay, so let's just kind of digest this a little bit. So we knew earlier we had that golden cupcake situation. We knew that we had one golden filling cupcake and we had 49 not golden cupcakes. Okay. So that meant for every one cupcake that had golden filling, there were 49 cupcakes that did not have golden filling. And if I took the favorable plus the unfavorable, it was the 50 cupcakes in question total. So we had these 50 cupcakes. We knew one had golden filling. We knew 48 did not have gold, or 49 did not have golden filling. But total, we still had 50 cupcakes. And that's important, understanding that you can add the favorable and the unfavorable to get like everything we need. Okay. So if the odds in favor of an event are A to B, so A to B, okay, then the probability of the event is going to be A all over A plus B. So if we want the probability of getting a golden cupcake, it would be, well, there's one golden cupcake out of 50 cupcakes total. So this would be the probability of the golden cupcake, okay? So probability and odds are definitely related, okay? So if you have one, you can find the other, all right? So again, if the odds in favor are A to B, the probability of event A happening, I should probably change this to A, would be A over A plus B. Okay, so example 6 says find the probability. Okay, so we're going to have odds. We need to convert that to probability. So at a local carnival, the odds in favor of winning a giant stuffed animal at the ring toss are 1 to 4. So 1 to 4 means 1 way to win, 4 ways to lose. Okay, so Total, if we look at the favorable, this is favorable, and this is unfavorable. We have 5 outcomes total. Okay. So if we want the probability of winning at the ring toss, we have one way we can win out of 5 possible outcomes. 1 win, 4 losses, 5 outcomes total. Okay. So the probability here, we would just take A and B and add them and then put A over A plus B. All right. Now, for part B, we got to do a little bit more work here. It says the odds against a particular horse winning a race are 15 to 1. Okay. Now, remember, when we talked about odds to probability, we were talking about if we have the odds in favor of something, we can convert that to probability. Well, in this case, they gave us the odds against, so keep that in mind. So the odds against a particular horse winning a race are 15 to 1. Okay, find the odds in favor of the horse winning first, and then the probability of the horse winning. So, first of all, odds in favor. Now, remember earlier we were talking about odds in favor and odds against a red queen. So that was example 6A and B. And we noticed that the odds in favor and the odds against were just flip-flops of each other. So if you're talking about the same event, the odds in favor, in this case, were 1 to 25. The odds against were 25 to 1. Same thing's going to happen down here with the horse race. If we know the odds against a horse winning are 15 to 1, that means the odds in favor of the horse winning are 1 to 15. So let's say this is A, this is B. Let's figure out what A plus B is. That would be 16, okay? So if there's one way to win, there's 15 ways to lose, basically, okay? So if we want the probability of a win, well, we would take the ways we can win. There's one way to win. And then we would take the ways to win and the ways to lose, add those, and that becomes all the possible different outcomes. So if the probability of a horse winning a race are 1 in 15, let me say that again. If the odds in favor of winning a race are 1 in 15, the probability of winning the race is 1 out of 16. Okay? So that's odds and probability. We've done quite a bit so far. We did the not probabilities, we did mutually exclusive with or, not mutually exclusive with or, empirical probability, and then we also did odds and probability. In the next section, we're going to talk about and probabilities. That's like things in a row. And then we will also talk about something called conditional probability.